Right, today we're looking at November 2011 A-Level Maths Paper 1. So this is a very long one, 3 hours. So let's check it out. Number 1 says, sketch on a single diagram the graph of y equals to modulus of 3x plus 2 and y equals to negative x plus 1. Hence or otherwise, find the set of values of x which satisfy this equation here. Okay, so first we need to sketch that one. Okay, so sketching this linear graph is very easy. First we have this one. What I can do is use my knowledge of transformation to actually draw these ones here. Let me start with the Cartesian. Then I know that y equals to negative x is a reflection on this on the y-axis of our equation y equals to x. So if I reflect that one, it will pass at 1 and be like this. So this is my y equals to negative x plus 1, and then here I've got 1. Then this one, 3x plus 2 here, I can find maybe points when y equals to 0. My x is equal to negative 2 over 3. Then when my x equals to 0, my y is equal to what? Is equals to 2. Okay, so I know that it crosses at 2 there. Then it crosses here at negative 2 over 3 also. So I know that it will come like this. So then bounce there and go like so. Okay, so which means I've got two intersections here, this intersection and this intersection there. Okay, so let's label this one as y equals to 3x plus 2. Okay, then we have done with the sketching. Now we need to find the set of values for which satisfy this equation. Okay, so in other words, we need to solve this inequality. So there are two ways of doing this. The first one is to separate this one. It is given like this, as a 3x plus 2 less than minus x plus 1. I can separate this one and say negative 3x plus 2 less than negative x plus 1. And another part is what? 3x plus 2 less than negative x plus 1. So I'm going to solve this 2. First, this one, I'll leave this one going the side. So it's going to be what? 4x less than what? This 2 going there, and giving me negative 1. So my x is less than negative 1. First one. Then the second one, I'm coming to this one, negative 3x minus 2 less than negative x plus 1. So this x, this going there, I've got 2x less than this one going there, I've got negative 3. So I've got my negative 3 over 2 less than x. Okay, so having this one and this one, I need to try and combine them if they agree. So if I put x in the middle and say x is what? Is greater than this one, negative 3 over 2, and then x is less than negative 1. In fact, here I made an error. It's supposed to be 1 over 4. So 1 over 4. So this is our solution. If you look at the equation, this region here in the middle, this region is the only region where our this one is lower than this one, just like what our inequality is saying there. Okay, now we're moving on to number 2. Number 2 says the cubic polynomial f of x is given by this one, where k is a constant. The function, this one, f of x leaves a remainder of 6 when divided by this one. So in other words, that statement is saying that if we say f of what? If we say f of negative 2, we are going to remain with 6, which is our remainder there, because we're dividing by this one, which is x plus 2 equals to 0, then x equals to negative 2. So if you put negative 2 for x here, you are going to remain with 6. So let's do that. So I'm going to come here and say 2 negative 2 cubed plus 6 negative 2 squared plus k negative 2 plus 12 equals to 6. Then if I solve that one, I'm going to get that k equals to 7, right? So I've got my k as 7. The solution for the equation f of x equals to 9, given that it has only one real root. Okay, so let's solve that equation when it is equated to 9. So what we have is this one. This was our a. Then our b, we have what? 2x cubed plus 6x squared plus 7x plus 12 equals to 9. Okay, so if I take this 9 to the other side here, I'm going to get what? I'm going to get 2x cubed plus 6x squared plus 7x plus 3. Okay, then this one is a factor. You find that factor by inspection or by trying. So typically you try 1 and negative 1, 2 and negative 2, 3 and negative 3, and maybe 4 and negative 4. If this one do not work, most likely your factors are not as easy to find. So I tried and I found that negative 1 works. So f of negative 1 is giving me 0. So which means this one, x plus 1, is a factor. So if it is a factor, I can divide with it. So let's divide with that one. And this one is 2x cubed plus 6x squared plus 7x plus 3. Then x into 2x cubed is 2x squared. 2x squared times x gives me 2x cubed. Then 2x squared times 1 give me 2x squared. Then I subtract it there, I get 4x squared. Then x into that, I get plus 4x squared plus 4x. I subtract again, I remember with 3x. Then x into 3x is plus 3. Then 3x plus 3. Subtracting that one, I get 0. So my roots, my factors now, I have x plus 1 and 2x squared plus 4x plus 3, the one that I found here. So I need to find the factors of this one, and of which, since they told us that it has one real root, this is the real root here. Now here we're supposed to use the quadratic formula to find the complex roots. So let's do that. The quadratic formula is what? X equals to negative b plus or minus root of b squared minus 4ac over 2a. So let's do that. Our minus b there is minus 4 plus or minus root of 4 squared minus 4 times 2 times 3, which is going to give us over 2a. There is over 4. This is going to give us what? Minus 4 plus or minus root of what? Root of 4, 16 minus 24 over 4. Then I'm going to just put this one on the calculator first, and it's going to give us what? Minus 1 plus root of 2i over 2 and minus 1 minus root of 2i over 2. So these are our other two roots. The first one is what? It's negative 1. Number 3, describe the transformation needed for the transformation of this one onto this one. So 6 sine 2x, we have y equal to sine x onto y equal to 6 sine 2x minus pi. Okay, so there's this pi means that it's a downward transformation in parallel to the y-axis. Downward translation parallel y-axis. Okay, then that this 2 here, it means that it is a one-way stretch by factor of half. Then this is 6 on the outside, means the one way stretch by factor 6 parallel y-axis. Here is parallel x-axis. Okay, then we're moving on to B. B says what? A curve is given by this equation. Find the equation of the normal to the curve at that point in form this one. Okay, so we have a curve there. To find the equation of the normal, first find the gradient at that point, then find the gradient of normal, then create an equation. So let's do that. Okay, so our equation y equals to x squared minus 4 over x plus 1, then dy over dx equals to 2x over x plus 1 minus x squared minus 4 over x plus 1 squared. So that is differentiation. If you don't know how I did it, use the quotient rule. So at this point now, at our point 2, 0, we've got dy over dx being equal to, substituting our 2 for x, we get 4 over 3. This is the gradient of tangent at that point, which I am going to call mt, which is 4 over 3. Now mt is -1. So let's find mn. So mn equals to -1 over 4 over 3, which is -3/4. Now having that one, we can find the equation very easy. So what is the equation now? Equation is -3x minus 2 equals to y minus 0 times 4. Then -3x plus 6 equals to 4y. Then going to the other side, the right side, we have got the 3x plus 4y minus 6 equals to 0. So this is our equation there. Number 4 says, at time t equals to 0, the area of a circular pond is 36 square centimeters. The radius of the pond is increasing at a constant rate of 1.1. Find the rate at which the area is increasing at the instant when area is 144. Data that I have. Okay, we have that at t equals to 0, we have the following. We have got a equals to 36 pi, which makes r equals 6, and the formula for area is a equals to pi r squared. I can also find dA over dr there, which is a 2 pi r. I'm also given that dr over dt equals to what? 1.1, which is constant, centimeters per second. Okay, then now the question says, if a equals to 144, how can I get my r? I can say my r is 144 equals to pi r squared. So my r equals to 12 root of pi. Okay, now that I have that one, I can then come here and say at this area here, my r is this. So at r equals to 12 over root of pi dA over dr, the one that I had here, this one, I can sub for r there and find its value. So dA over dr equals to what? Equals to 2 pi r, then r I substitute 12 over root of pi. This is going to give me an answer which is what? Which is 24 root of pi. So now that I have all these ones, I can now find what I'm looking for, which is a dA over dt, which is equals to dA over dr times dr over dt. So the way you make this a chain rule equation is to make sure that if you cancel here, it is going to remain the same as this one. So that's what you use there. And then what you now do is you say this one here, which is a 24 root of pi times 1.1, and it's going to give you what? It's going to give you 46.79 as our answer there. So let me write it here. dA over dt equals to 46.79 square centimeters per second. The next question says, find the rate at which area is increasing at an instant when time is 10 seconds. Okay, so B, let's do B. So rate is constant, so gradient, it means that the relationship is in form y is equal to mx plus c. That's when you get a constant rate, or this rate is same as gradient. So if you have a graph like this, your rate is not constant because the gradient is not constant. But if you have a graph like this, your rate is constant. So the equation is in this form. So what you need now to figure out is the relationship between r and t. So r equals to the gradient, which is 1.1 t plus c. At t equals to 0, r equals to 6, because I also add this one here. It comes from our data here, because if a is 36 pi, it simply means that area is pi r squared. So that r is 6 squared, which is 36. So initially our r is 6, right? So having that one, we now know that our c is 6. So r equals to 1.1 plus 6. Here there's a t. Okay, now knowing that one, we can now find a r at t equals to 10. So at t equals to 10, our r equals to 1.1 times 10 plus 6, which is 17 centimeters. Okay, now having our r there, we can now find what dA over dt. We say it is 2 pi r. So if we say 2 pi times 17, we are going to get a 34 pi. Then our dA over dt is equal to this 34 pi times 1.1. The reason why I'm saying this is because of this statement here, this one, dA over dr times this 1.1 here. So that's where I'm getting that one from. So here we're going to get what? We're going to get 117.5 square centimeters per second. So that is the answer for number 4. So we're done with number 4. Let's move on to number 5. Number 5 says express this one in partial fraction. Okay, so let's do that. We've got 3 over x squared x plus 3 equals to a over x squared plus b over x plus c over x plus 3. Okay, then equals to x identity to a multiplied by x plus 3. The reason we come up with this is because of this. Our common denominator is this one. So if you say this one into this one, it's going to cancel. It's going to cancel this one, and you are remaining with this. That's why it's multiplying a. Then if you say this one into this one, it's going to cancel only one x there. So your result is going to be what? It's going to be plus b ax, then x plus 3. Then now this one, if you take this one into there, it's going to cancel this one, and then we are going to remain with what? We are going to remain with the plus c x squared. I'm going to do quick this partial fraction. When x equals to 0, we've got what? We've got a equal to 1. Then when x equals to negative 3, we've got c equals to 1/3. Then if we say x equals to 1, we've got 3 equaling 4a plus 4b plus c, which gives us our b is equal to negative 1/3. Okay, having that one, we can rewrite this one as 1 over x squared minus 1 over 3x plus 1 over x plus 3 as our answer. Then next, b says hence evaluate the integral of this function from 2 to 4, leaving your answer in exact form. So we're supposed to integrate that result. So from 2 to 4 of 1 over x squared plus minus 1 over 3x plus 1 over x plus 3 dx. So let's integrate that one. Our answer is going to be negative 1 over x minus a third ln x plus a third ln x plus 3 from 2 to 4. If we put our limits, we get what? Negative a quarter minus a third ln 4 plus a third ln 7 minus negative half, negative a third ln 2 plus a third ln 5. Okay, so let's remove this negative here, this one there. We're going to get negative a quarter minus a third ln 4 plus a third ln 7 plus half plus a third ln 2 minus a third ln 5. Then these lns, I can apply the laws of logarithm on them. So this half and negative quarter will give me a quarter. Then these that have a positive 14, which is 7 times 2, 14, over this one that have a negative will multiply, then come here. So it's going to be what? 20. So this is what we have now. We can simplify further there and say a quarter plus a third ln 7 over 10. This is our exact answer there. Number 6 says the points O, P, Q, and R form a parallelogram where O is the origin. So O, P, Q, R. The position vectors of P and R are, for P we have what? We have 1, lambda, 1. Then for R we've got what? We've got a 4, 0, 2 respectively, where lambda is a positive. Take note of positive constant. The angle OPR is a right angle. This one, this angle is a right angle. So find the value of what? The value of lambda. Okay, so how can we go about that? So we know that this one is a right angle now, so which means if you do a dot product of this one, which is PO and PR, it is going to give you 0. So you can come up with some equation there. So let's do that. So first let's find PR. PR equals to R minus P, which is equal to what? Equals to 402 minus our P, which is 1 lambda 1. Then it's going to give us what? 3 negative lambda 1. Now knowing this one, if we say a PR dot PO, is going to give us 0, just like I was explaining there. So it's 3 negative lambda 1 dot this one is now times negative 1, because what we're given is OP. This is now PO, so you're saying times negative 1. So times negative 1 with negative 1, negative lambda, and negative 1, which is going to give us what? A negative 3 plus lambda squared minus 1 equals to 0. Then lambda squared equals to 4. Then lambda equals to plus or minus 4, but they specifically say it is a positive integer, so we're taking 4 there. Then next we are on B. We say find the position vector of Q, this one. Okay, so how can we find the position vector of Q there? We have this direction here. We can take this one, then this one OR we know is this one. Then this one here is same as this one. Okay, so if you take this one, since they are parallel, we now know that this one is same as this one. So let's find our OQ. So OQ equals to OR plus OP, which is what? Our OR is what? 402 plus our OP is what? 1. Our lambda we said is 2, then 1 there. So adding those ones, I get what? 5, 2, 3. This is our OQ. Then let's proceed. Our C says find the exact area of our parallelogram. We're finding the area of our parallelogram, which is what? Which is half base times height. Okay, but we have 2 here because a parallelogram is made of 4. You can split it into 2 triangles. So since it's a full, it's already 2 triangles, so there's no need for us to say half. So we can remove this one and just say base times height. So what is our base there? Our base is the magnitude of OP. Then our height is magnitude of PR. Okay, let's go back here. Okay, so this is our height here. Then this is our base. What is the magnitude of OP? OP is a root of what? Root of 1 squared plus 2 squared plus 1 squared times magnitude of PR. So if you simplify this one, it's going to give you what? Root of 84, which is same as 2 root of 21 is our answer. So this is all about number 6. Now we are on number 7. Number 7 is a shape, and the question says the diagram above shows a circle of radius r and center O. The shaded region is bounded by the chord AC. Okay, the diameter AB and arc BC, and the angle BAC is theta radians. Find the exact expression in terms of form r and theta for the perimeter of the shaded region. Okay, for the perimeter we know this one, which is a 2r. We know this one because it is what? It is a perimeter of a sector. Okay, then here let's split. Then we have this angle here. If this one is theta, it means this one is also theta. Then this one is 2 theta. Okay, so what is the perimeter of a sector? Perimeter of a sector is 2 theta r. So now we want the perimeter of this one. How can you find that one? We can use the cosine rule, where we say we have AC here and we have r there, then we have our theta there. So let's do the cosine rule. I'm going to write the cosine rule here. So cosine rule says cos theta equals to AC squared plus r squared minus r squared over 2AC times r. So what is going to happen is that these ones will cancel each other since they are subtracting. So what we are going to remain with is what? AC squared over 2AC equals to cos theta, and here we are going to cancel here. Here we have r again. I'd forgotten r there. So what is going to happen? We're going to have this r and 2 going to make us 2r cos theta equals to AC. So now we have this one as our AC. So number 7a, our perimeter equals to what? Equals to 2r plus 2 theta r plus 2r cos theta. Okay, now I can factor out the 2r there, and you have 1 plus theta plus cos theta as our perimeter. Okay, now B says what? Given that theta is a pi over 6, calculate the exact area of the shaded region in terms of r. Area of shaded region, we can split it again. So let me clear the area there. We can split it again and find the area of two things there. So let's split it into a sector and a triangle. This one we know that is 2 theta. Okay, then here we know that is theta. We know the area of a triangle and area of a sector. So let's come for area here. Say A equals to a triangle plus area of a sector. Area of a triangle is half AB sine theta plus area of a sector is what? Is half r squared theta. So our area is going to be half. Our A is r, our B is AC, which is 2r cos theta. Theta is pi over 6. Then sine theta, our theta is pi over 6 plus half r squared. Then our theta for this case is theta for the sector, which is 2 theta there. So it means here we've got a 2 theta, which is a 2 times pi over 6. Then let's simplify all that. After simplifying, we're going to get what? We're going to get a r squared, a root of 3 over 2 times half plus half times pi r squared over 3, which will equal to r squared root of 3 over 4 plus pi r squared over 6, which is going to give us r squared over 12, 3 root of 3 plus 2 pi. So this is our area there. Then now on number 8, the question says the function h of x equals to 2x squared minus 6x plus 11, where x is an element of real numbers. Express h of x in this form here, a x plus b squared plus c. Okay, so that is completing a square. So let's complete a square there. Completing a square, I take 2 outside and remain with x, a minus 3x plus 11 over 2. Okay, then I put 2 outside again, I remain with x minus 3 over 2 squared minus 9 over 4 plus 11 over 2, like this. So I'm going to get what? I'm going to get 2x minus 3 over 2. Then I get what? Plus 13 over 4. Okay. Now this is equals to 2x minus 3 over 2 plus 13 over 4. So this is our form. Then write down the range of h. Okay, what is the range of h? This was a, then b, range of h. A, we said it's what? A, we said it's 2x minus 3 over 2 squared plus 13 over 2. Then b, the range we say that h of x is greater than or equal to this value here, which is 13 over 2. Then on c, what does the question say for c? C says explain why h does not have an inverse, because it's not a one-to-one mapping. So here not 1-to-1. Okay, then checking d, we have item 1 and 2. Given that h of x is defined for x is an element of a, where a is a subset of real numbers, find the largest element of a for which h has an inverse. So let me explain how we find that element. So what we have here is a quadratic in this form. So what it means is that, for example, this value for x might be linked to here, then linked to here. So which means this value for y here is not 1-to-1. It has 2 values of x. That is what we don't want. That is what stops this function from having an inverse. So what we need to do now is to find a value that is here, so that this side is 1-to-1. So what is this value here? This value, we found it by saying this is d item 1, by saying x minus 3 over 2 equals to 0, then x equals to 3 over 2. We're taking this value here, this one, from our completed square. We're taking this value here. Okay, then item 2 says find inverse of h for this set of elements. So now that we've defined that new domain, we can now find the inverse. So let's find the inverse. So to find the inverse, you simply make x the separate formula. Then when you're done, you simply switch x and y. So let's do that. So you say y equals to 2x minus 3 over 2 squared plus 13 over 2. Okay, so now we need to make x the separate formula. How can we do that? We can say 2x minus 3 over 2 squared equals to y minus 13 over 2. X minus 3 over 2 squared equals to y over 2 minus 13 over 4. Okay, then we can apply the square root both sides, and we get a square root of 2y minus 13 over 4. Then we get what? Equal to x minus 3 over 2. Then we got x equals to 3 over 2 plus or minus root of 2y minus 13 over 2. Okay, then x equals to 3 over 2 minus root of 2y minus 13 over 2. The reason why we're eliminating the plus here is because of our domain, which said this one is a maximum, so we don't want anything that adds to this one. So here we're going to have something that subtracts from that one. So here we can then say y equals to 3 over 2 minus root of 2x minus 13 over 2. So hx negative 1 equals to 3 over 2 minus root of 2x minus 13 over 2. This is our inverse there. Number 9, it is given that f of x equals to 1 over 1 plus x squared plus root of 9 plus x. Expand f of x up to and including the term x squared, simplifying the coefficients. Okay, so here we have two entities here. We've got 1 plus x to the power negative 2 and 9 plus x to the power of half. This one we can further simplify into 9 to the power of half, then 1 plus x over 9 to the power of half. Okay, so let's bring this one down here and have what? Our formula for 1 plus xn expansion equals to 1 plus n over 1 factorial x plus n minus 1 over 2 factorial, then x to the power of 2. Okay, so let's take our first one, which is 1 plus x negative 2. Then if we plug in the formula there and simplify, we're going to get 1 minus x plus 3x squared plus. Okay, then if we take the another one, which is 9 to the power half, then 1 plus x over 9 to the power of half, we're going to get 3 plus x over 6 minus x squared over 216 plus, after simplifying. So now we're supposed to add that one to get our final, and after adding we get what? We get 4 minus 11 over 6x plus 647 over 216 x squared plus. Okay, so this is our answer for that one. Now let's move on to B, which says state values of x for which this expansion is valid. Okay, so this expansion is valid for x is between negative 1 and 1. This is B. This was A, number 9. So now we are moving on to number 10. Number 10, A says the complex number u is such that negative 4 plus 3i times u equals to 5 minus 3i. Find the modulus of u. Okay, and then argument of u. So the approach here is to what? The approach here is to say, is to divide by this one both sides and remain with u equals to 5 minus 3i over negative 4 plus 3i. Then you rationalize by multiplying by negative 4 minus 3i by negative 4 minus 3i. Okay, then after rationalizing, you're going to get your u as what? As 29 over 25 negative here minus 3 over 25i. Okay, so we want the modulus of u, which is equals to square root of 29 over 25 squared plus 3 over 25 squared, which is going to give us what? Root of 34 over 5, which is equals to 1.166. Okay, then B, we want the argument of U, which is equals to tan negative 3 over 25 times 25 over 29. This is going to give us what? 5.91 degrees. Okay, so an argument is not as easy as that. So we have quadrants here. Since these two here are negatives, it means we are on this quadrant here. So if we are on this quadrant, we want this angle. What we just found is this one, but we want this one. So how can we find that one? We are going to say what? We are going to say our angle, which is 5.91 minus 180 degrees, which is going to be negative 174.1 degrees. So this is our argument. Then moving on to B item 1, given that the complex number W is 2i, find in form A plus B I U over W. Okay, so let's come here. This is B item 1. U over W is negative 29 over 25 minus 3 over 25 I over W, which is 2i. Then now we rationalize by saying my times 2i times 2i. Then we are going to get what? We are going to get, after simplifying, we get negative 3 over 50 plus 29 over 50 I as our answer. Then item 2 was supposed to find U, W, so we simply multiply there, which equals to 2i times negative 29 over 25 minus 3 over 25 I. This is going to give us what? 6 over 25 minus 58 I over 25. As simple like that. And then next, so we're done with number 10. Let's go to 11. Number 11, we're given a graph there. Okay, so the question says the diagram shows the region R1 and R2, this one and this one, enclosed by the curve, this one, y equals to 1 plus sine 2x, and the line x equals to pi over 4, and the axis, the line y equals to 1, divides the two regions. Like here, use the trapezium rule with 4 equal intervals to find an approximate total area of R1 plus R2 correct to 3 dp. Okay, trapezium rule. So the formula for trapezium rule is what? We know that A equals to half of H first plus last ordinate plus 2 sum of the rest of coordinates. Okay, so let's find H. H equals to what? Distance here divided by number of intervals. So if you say quarter divided by 4 intervals, because they said 4 equal intervals there. So if you say pi over 4 divided by 4, it's going to give us pi over 16 as our H. So we have our H. Now we need to find those ordinates or those intervals. So let's do a table here. Okay, then we've got a what? We've got x here, and then we've got a y here. All right. So let's find that area under the graph. So here we've got 0, we've got pi over 16, we've got pi over 8, we've got 3 pi over 16, then lastly we've got pi over 4. So what we do, we come to our y equals to, what is that function? 1 plus sine 2x, 1 plus sine 2x. Then we substitute for x there. Then if you put 0 there, we are going to get 1. If you put pi over 16, you're going to get 1.3827. then next 1.7071, then next 1.9238, then next you're going to get 2. Okay, so this is our first, and this is our last, then these are the rest. Okay, so let's come back here and do that. Here we are using this function, we are using this one only because everything here is under that function. We don't need to consider this one, this one here. We're just considering everything under the curve there. So there's no, that's why we are not including this one. So let's see, let's plug in our values. So a equals to what? Equals to pi over here, which is the same as a pi over 32, 1 plus 2 plus 2, 1 plus 3827 plus 1.7071 plus 1.9238238. Okay, then our answer there is going to be 1.2789, which is same as 1.279. Okay, this is our answer there. Then B says find in terms of pi the volume of the solid revolution obtained when R1 is rotated through 2 pi radians about the x-axis. So what is the volume? We have a formula here for B. Volume is equal to pi, okay, of y squared dx. This dx is determined by whether we are rotating about the x or y axis. So in this case it's x-axis, that's why we're using dx. Now there's a little trick because we're looking for R1 only. So which means we want when this region here is rotated, this one. So which means we need to find for whole region minus for this region. That's why we're going to get this one. So we are going to say what? We are going to say pi from 0 to pi over 4, 1 plus sine 2x minus pi from 0 to pi of 1 dx. Okay, the reason why we're saying 1 is because this one y equals to 1, then this one y equals to 1 plus sine 2x. Okay, so let's finish that one up. Because our volume is saying squared, so these are squared. So let's proceed. Pi from 0 to pi over 4, 1 plus sine 2x squared minus a from 0 to pi over 4 of 1 dx. Okay, so we need to expand this one here. So let's expand that one. We are going to get 1 plus 2 sine 2x plus sine squared 2x. So this one, we need to remove that squared there because you cannot integrate that one. So to do that, you need to use the cosine double angle. So that sine 2x squared is same as half minus cos 4x over 2. Okay, so let's come back here. Pi from 0 to pi over 4, 1 plus 2 sine 2x plus half minus cos 4x over 2 minus 1 there. Okay, so this is going to be what? 0 to pi over 4 of 3 over 2 plus 2 sine 2x minus cos 4x over 2 minus pi 0 to pi over 4, 1. Then integrating that one, we get what? We get pi x over 2 minus cos 2x minus plus sine 4x over 8 from 0 to pi over 4. Then putting our limits there, we've got what? Pi over 8 times pi minus pi times -1, which give us what? Pi squared over 8 plus a pi. So this is our volume there. So this one was a long one, that's why it is a 6 marks. Then number 12 says, number 12a, sketch on the same axis the graph y equals to 2x and y equals to tan x, where x is between 0 and 3 over 2 pi. So let's do that one. So we've got our Cartesian there, 0, pi over 2, which is 90. Then we've got a pi. Then we've got 3 pi over 2. Okay, that is the same as 270. So we know that tan doesn't touch these lines. So which means the equation for tan will be doing this. Then the side is going to do this. Then our y equals to 2x is going to be doing this. Okay, so here we have an intersection. Y equals to 2x, then y equals to tan x. So we're done with the sketching. B says show that the smallest positive root of 2x minus tan x equals to 0 lies between x equals to 1 and x equals to 1.5. B, and they were given that 2x minus tan x equals to 0. So the way you approach this one is what? Is to say f of x equals to 2x minus tan x. Then you say f of what? Of 1 equals to 2, put 1 there, minus tan 1 is going to give you 0.44. Then we say f of 1.5, this one is going to give you negative 11.10. So therefore there is sign change, which implies that root lies between 1 and 1.5. Okay, so this sign change is a way of checking if a root lies between two values. Then C says, starting with the x0 equals to 1, use Newton-Raphson method to find the smallest possible root of 2x minus tan x, giving your answer correct to 3 dp. Okay, so let's do the Newton-Raphson method for C. The formula is like this: xn plus 1 equals to xn minus fx over f prime x. Okay, our fx equals to what? Equals to 2x minus tan x. Then our fx prime, or first derivative, equals to 2 minus sec squared x, which equals to 2 minus 1 over cos squared x, right? Then the way you do it, you create a little tape here where you have your n, then your xn there. So when n equals to 0, they told us that we use a 1. So what you're going to do is substitute there. Let me do the first one where our n is 0. So which means our x1 equals to what? Equals to 1 minus 2 times 1 minus tan, and then put 1 there. Then 2 minus 1 over cos 1 squared. Okay, then you're going to do and get your answer there. So it's going to be 1.3105. Then you take this one now. This one is now your x1. So you're going to substitute there to find your x2. So you're going to get another value, which is 1.1761. Then for 3, you're going to get 1.1659. For 4, you're going to get 1.1656, and so on. For 5 is 1.1656. So your answer x now, we are taking this one and this one and this one are not changing, so which means it's now becoming constant. It's getting closer and closer to your real value of x. So in 3 decimal place, we can simply take 1.16 6. This is our answer there. Number 13a, show that the equation 3 sine x plus 5 cos x cot x minus 4 equals to 0 may be written in form a sine squared x plus b sine x plus c equals to 0, where a, b, and c are constants. This is number 13a. We're given 3 sine x plus 5 cos x cot x minus 4 equals to 0. Okay, so let's say 3 sine x plus 5 cos x, then cot is what? Is cos x over sine x minus 4 equals to 0. Okay, so what can we do now? We can multiply everything with that sine x on the denominator there, then get 3 sine squared x plus 5 cos squared x minus 4 sine x equals to 0. Okay, then we are going to convert that cos squared in terms of sine, so the same as 5 1 minus sine squared x minus 4 sine x equals to 0, 3 sine squared x. Then let's simplify that one. Then after simplifying, we're going to get a 2 sine squared x plus 4 sine x minus 5 equals to 0. So we have shown this one. Then b says here, so otherwise solve the equation. This one equals to 0, where our theta lies between 0 and 360. Okay, so in other words, we are solving this equation. So I'm going to use the quadratic formula there for b minus b plus or minus b squared minus 4ac over 2a. It's going to give me sine x. Okay, so sine x equals to what? Sine x behaves as x in this case, so we're going to have negative 4 plus or minus root of 4 squared minus 4 times 2 times 5 over 2 times 2. Now we are going to get sine x equals to negative 1 plus root of 3.5, or negative 1 minus root of 3.5. Then now I can find x there. X equals to arc sine of that one and of this one, right? This one is negative 1 minus something, so this one is undefined here. So our sine line lies between negative 1 and 1, so this one is undefined. Then this side, we are going to get what? We are going to get 60.56 degrees. Then to get the other one, we need to say 180 minus 60.56, which is going to be what? 119.44 degrees. So our values for x now, we've got 60.56 degrees and 119.44. Okay, so the reason why we are saying 180 there is because of the graph of sine. Let me explain it here. It is like this, then the sine moves like this, where here you've got, we have 180, then here you've got 90, so here we've got around 60 there. So if you have got a 60 there, which is your value for y, which means you also have this one here, this one. So this one here is the one that we are finding when we're saying, when we're doing this. So let's move on. See, item 1 says express this one in form this one, where r is greater than 0 and alpha lies between 0 and 90. Then after that, we are supposed to solve it. see item 1, we've got 5 cos x plus 6 sin x in this form here, which is r cos x minus alpha. So what you do is expand this one. It's going to be r cos x cos alpha minus r sin x sin alpha. Then we are now equating those that have cos x. So 5 cos x equals to r cos x cos alpha. Then this one will cancel, and then you remain with 5 equals to r cos alpha. Then you do the same thing for sine, and you're going to remain with 6 equals to, here I made an error, it's supposed to be plus, so you're going to have r sine alpha. Now having these ones, we can find our r and find our alpha. So this is equation 1, and then this is equation 2. So if we divide 2 by 1, we're going to have what? Sine alpha over cos alpha equals to 6 over 5. Then sine over cos is tan, so tan alpha equals to 6 over 5. Then alpha equals to tan of 6 over 5, which is going to give us what? 50.19 degrees. Then for our r, we're going to use this concept here, which says a cos squared theta plus sine squared theta equals to 1. So what we can do is square this side and that side and that side and that side. After squaring, we add. So if we square and add, we're going to get that r squared equals to 6 squared plus 5 squared. So r is root of 36 plus 25, which is root of 61. Okay, then our answer now is a root of 61 cos x minus 50.19. Okay, then the question further says hence solve this equation. So you've got a root of 61 cos x minus 50.19 equals to what? Equals to 4. Okay, so let's solve that one. We are going to say our x minus 50.19 equals to a cos of 4 over root of 61, which is going to give us what? 59.19. Then to get the other one, we're supposed to add 360 here. So if you add 360, you're going to get a value that is too high. Okay, so if you get a value that is too high, you cannot put it here. So what you do, subtract this one from 360. So if I subtract this one from 360, I'm going to get 300.81. So those are two values. Then x equals to what? Taking this 52, add this side and this side, I'm going to get what? X is equals to 351 and 109.4 degrees. Item 2, we say state the minimum and the maximum values of that one. My maximum value equals to root of 61, then mean equals to negative root of 61. Okay, number 14a, find the solution of this differential equation, this one, given that the curve passes through this point. So let's go and solve that differential equation. So you've got x dy over dx equals to y plus yx at our point, which is what? 2, 4. So let's solve that one. We need to collect all y is to one side and all x is to one side. So here I'm going to say this side I'm going to factor out y, and I have 1 plus x. Okay, x dy over dx. Then I'm going to divide by both the x and y per side. So here I'm going to get what? 1 over y dy over dx equals to 1 plus x over x. Okay, then now I'm going to take this dx to the other side and remain with the 1 over y dy equals to, I can simplify that one into 1 over x plus 1 times our dx. When you're at this stage, that's when you put your integral signs both sides and then integrate. Here you're going to get ln y equals to ln x plus x plus c. Okay, when we're here, we now say you are given your point, this one here, you're now substituting for x and y to get c. So ln 4 equals to ln 2 plus 2 plus c. So c equals to ln 2 minus 2. Okay, right, so having that one, I can rewrite my solution as ln y equals to x plus ln x minus 2 plus ln 2. So this is my solution for that differential equation. B, we're given a story there which says a water tank has the shape of a cuboid with base area of 4 and height of 3 meters and is initially empty. Water is poured into the tank at a constant rate of 0.05. There is a small hole at the bottom of the tank through which water leaks out. The depth of the water in the tank is h meters when water has been poured in 40 minutes. In a simple model, it is assumed that water leaks out of the tank at a constant rate of 0.025. So 1 says show that the variable h satisfies the differential equation. Okay, so this one, let's try to squeeze it here. We say dh over dt equals to dv over dt divided by dv over dh. Okay, we know our dv over dt, it is the difference of this one here, the rate of pouring in, and this one, the rate of leak. So it is going to be what? 0.05 minus 0.025 is going to give us what? It's going to give us 0.025 over. Then to find our dv over dh, we know that v equals to what? Equals to a, which is our base area there, 4 times what? Times height, because volume is base area times height. So this implies that our dv over dh equals what? To 4. So that's why we're getting this 4 here. Then this one is same as what? Same as 1 over 160. So it is shown now. It is shown that this one is true. Then moving on to 2 there. Yeah, so otherwise find the time when the tank starts to overflow. Okay, so we need time when the tank starts to overflow. It overflows when our h here is now at what? At this 3 meters here, because we're told that our height, the height of tank is 3 meters. So that's when overflowing takes place. So let's find that time. Let's come here and use this one here. So here we want to find t. What we can do is separate that one into dh equals to dt over 160. Then integrate both sides. Then get h equals to t over 160. Then if our h is 3, it means that 3 times 160 equals to t. Then our t now equals to what? To 480 minutes. This is when it starts to overflow. Okay, then now we are on item 2, which says in a more refined model, the variable h satisfies the differential equation. This one, solve the differential equation expressing h in terms of t. So the differential equation is given as what? As 160 dh over dt equals to 2 minus h. So let's solve that one. First, you separate it there, and you remain with what? dh over 2 minus h equals to t over 160. Okay, then you apply your integral signs there, then you integrate, then you get a negative ln 2 minus h equals to t over 160 plus c. Okay, so we are told that initially this tank was empty here, initially was empty. So if it is empty, it means that our height is what? Is 0. The height of water is 0. So it means that here we've got what? We can find our c. So let's substitute there for h and t, and we're going to get what? We're going to get our c equaling negative ln 2. Now having our c, we can go back and resubstitute in the equation, which is negative ln 2 minus h equals to t over 160 minus ln 2. Okay, now we've resubstituted in the equation. Now we need to simplify that one. We can take this one to the side and it's going to be plus. So if it is plus, by laws of logs, it means it's going to be log, which is ln in this case, 2 over 2 minus h equals to t over 160. Okay, having that one, we can apply e both sides like so. So we're going to get what? 2 over 2 minus h equals to e to the power t over 160. Now having this one, we want to make h the separator formula, so we can multiply both sides by 2 minus h. So it's going to be what? 2 equals to 2e to the power of t over 160 minus h e to the power of t over 1 minus 160. Okay, so now we can divide with the negative e to the power t over 160 everything. Right, after dividing like that, we get negative 2 e to the power negative t over 160 equals to negative 2 plus h. Okay, then we can rearrange the and have h equals to 2 minus 2e to the power negative t over 160. Then factoring out 2, we've got 2, 1 minus e to the power negative t over 160. Okay, so this is our solution for that differential equation. So we've solved the differential equation. Now we're supposed to sketch the graph of h against t, right? Since we're transforming this thing upwards by 2, if you look here, we're transforming upwards by 2, so which means our 2 is our new asymptote, so it's the line that we're not supposed to touch. So now what we have is this one. Okay, so this is our graph there. H equals to 2 1 minus e to the power negative t over 160. Okay, so this is the end of this paper.